Hello, everyone. This video is of your practice exam number 1. This includes chapters 1 through 3. And I'm going to be using a PDF version of this, and the numbers in your practice exam will most likely be very different. But the type of questions should be the same, which again will mimic the actual exam. So let's jump into it. Question 1. The records for all trains scheduled to depart from the Opera House train station last year showed that the average delay for these trains was 12.7 minutes, 17.1% of the trains had been delayed, and 15 trains had been canceled. Rachel is a traffic engineer helping the Opera House station improve its performance. She audited a random group of 50 records of trains scheduled to depart from the Opera House station last year. In her group, the trains were late on an average of 21.3 minutes, 32% of the trains had been delayed, and 2 trains had been canceled. For Rachel's audit of train records, identify the population and the sample. Let's start with the population. Is it a random group of 50? No. This one is definitely going to be the records of all the train stations. And the reason we know that, this is the key, is that word right there. All. Versus a sample. And the answer for the sample is going to be the random group of 50 records audited by Rachel. It's important we know the difference between the sample and the population. Usually it's just a matter of reading the question carefully. Part B, choose whether each number described below is a parameter or statistic. Now, keep in mind, a parameter is for the entire population, and a statistic is only for a sample. The 32% of the random group audited by Rachel, so this is just the group of 50 that were audited by Rachel. This is definitely a statistic. The 12.7 minute average delay of all trains, there's the key there. This is definitely a parameter. And the 15 canceled trains among all trains, again, we see that all trains, that is definitely going to be a parameter once again. Let's move on. For each part below, indicate whether the variable is quantitative or categorical. Remember, quantitative means that we can attach meaningful numbers to the responses, and categorical is just groups. So let's take a look. Total elapsed time in seconds for completion of an assembly line operation. That is definitely going to be quantitative. Length in feet of a roll of plastic wrap advertised to be 30 feet long. That is quantitative. Eye color of the favorite singer. That is definitely going to be categorical. And temperature in degrees Celsius. That is also going to be quantitative. For whatever reason, when I made this into a PDF, it doubled this screen. So these are the exact same questions that we just answered. So I'm going to move on. All right, now we have 2 things to identify. We have the quantitative and the categorical. And remember, quantitative can be broken up into interval and ratio. Interval has no natural zero, whereas ratio does, and the ratios are meaningful, meaning you could say something like, this is twice the size of that, would be ratio. Categorical gets broken up into nominal and ordinal. Remember, nominal is just a grouping. Ordinal is a grouping, but there's a distinct order that's involved. So let's get started. Temperature in degrees Fahrenheit. That is quantitative because we can use numbers to measure that. But there is no natural zero when it comes to temperature. So that is going to be interval. I know there is a 0 degrees Fahrenheit, but it has no real meaning. Like 2 degrees is not twice the temperature of 1 degree, right? There's no meaningful ratio there. Part B, anxiety rating, highly anxious, moderately anxious, or relaxed. This is going to be categorical. And there is definitely an order involved. So this is going to be ordinal. All right, part C, university in which a student is enrolled. that is going to definitely be categorical. And that is going to be nominal because the order has no natural order, meaning we could put them in order of I don't know, population size or alphabetically or something like that. But that's, again, not a natural order. That's an artificial one that we would do. All right. Question 4. Determine whether it's discrete or continuous. Remember, discrete means that it is countable, and continuous means that it is not countable. Now, a lot of times students mix up discrete as being measurable. No, discrete is just countable. Can I count them on my fingers? So let's start. Part A, the time it takes to drive from home to work or school. So the time is definitely going to be continuous. Whoop. Part B, the mass of the solid impurities per milliliter in Los Angeles tap water. That, again, is going to be continuous. I can't count the solid impurities. Part C, the number of your fellow classmates who have used the World Wide Web for information on seasonal affective disorder. Now, the key word here is it's a number. So meaning we are looking at discrete in this case, meaning there's going to be a countable number of fellow classmates. You wouldn't say 1.5 of my classmates. That doesn't make sense. The intensity of a 1,000 hertz tone judged by a participant to be equally as loud as a 500 hertz tone of 50 decibels. That is definitely continuous. So we're here. All right, number 5. A political campaign wants to estimate the number of adult residents who voted in the last city election. Answer the following. Which of the following surveys probably would best represent the entire adult population of the city? 50 business owners are randomly selected, 28 are voted in the last election. No, doesn't say anything about business owners. 50 adult residents are randomly selected in the city, 22 voted last election. And the third one talks about senior residents. The statement above says nothing about senior residents. So this is definitely my better statement. And for part B, I'm going to need the percent. 22 out of 50 is the percent. Let's see what we get with that. 22 divided by 50. So that's 44%. Part B. There are 21,400 adults who live in the city. Using your answer from part A, meaning this percentage that we have here, estimate the number of adults who voted in the last city election. So this is going to be 44% times 21,400 times 21,400. So I am seeing that this is 9,416 adults. Is the answer I'm getting for that. There we are. Number 6. So this is going to be talking about methods of collecting data. And I'm going to read through each of them just so I can identify for you, because I don't know what you're going to get on your practice test or your exam. Everybody gets different problems. Part A. A botanist at a nursery wants to inspect the health of the plants at the nursery. Which of the following best describes a stratified sample of plants? Stratified, if you remember right, we break things into groups and then we test some from each group versus testing some of the groups, but each group that I test all of them. That would be a cluster. So we're looking for stratified. Let's look at the first one for part A. The botanist forms groups of 8 plants based on the heights of the plants. Then he randomly chooses 9 groups and selects all of the plants in that group. This is cluster, this first one here. So this is not our stratified. The botanist forms 6 groups of plants based on the ages of the plants in months. Then he selects 12 plants at random from each group. That is exactly the definition of stratified. So this is the answer that we're looking at. I'm going to read the third one just so we can identify what it is. The botanist assigns each plant a different number. Using a random number table, he draws 72 of those numbers at random. Then he selects the plants assigned to the drawn numbers. Every set of 72 plants is equally likely to be drawn. So this is clearly a random sample. Let's move on to part B. A facilities supervisor at a sports stadium wants to rate the condition of the seats at the stadium. Which of the following best describes a systematic sample of seats? Systematic, if you remember, is, for example, this first one, every fourth seat. So let's read it. The supervisor takes a list of seats and selects every fourth seat until 80 seats are selected. That is our systematic. Let's read the other two just so we can identify them. The supervisor forms 4 groups of seats based on the dates of the seats were last replaced. She then selects 20 seats at random from each group. That is the previous one, part A, that's the stratified. And the third one, all of the seats in the VIP section are easily accessible. So the supervisor selects 80 seats in this section. That's convenient sampling. That, of course, is a terrible way to gather data. Part C. A chemist at a pharmaceutical company wants to test the quality of a new batch of microscopes. Which of the following best describes a random sample of the microscopes? First part. The chemist takes a list of the microscopes and selects every 6th microscope until 60 have been selected. That's going to be the systematic. Second one, a chemist forms groups of 12 microscopes based on the laboratories that the microscopes are in. Then he randomly chooses 5 groups and selects all of them. That's cluster. So that's not it either. Again, we're looking for random. The chemist assigns each microscope a different number. Using a random number table, he draws 60 of those numbers at random. Then he selects the microscopes assigned to the drawn numbers. Every set of 60 microscopes is equally likely to be drawn using the random number table. That is our random there. So there is our answer. All right, moving on. All right, here are the shopping times in minutes of 9 shoppers at a local grocery store. Complete the group frequency distribution for the data. In the distribution, the frequency of a class is a number of shopping times. Yes, I understand. And we'll note that the class width is 6, meaning if I go from 15 to 21, I'm adding 6. So how many of these are between 15 and 20, including 20s? We have here 15. We have 19. We have 20. So I'm seeing, it looks like we have 3 here. And from 21 to 26, let's see, 21 to 26, I'm only seeing the 1. So it's going to be 1. And 27 to 32, I'm seeing here, here, and here. That's 1, 2, 3, 4, 5, I'm seeing. So here's our frequency distribution table. All right, you could put those 9 numbers into a list and sort them in order. That could make it a little bit easier, but there's so few numbers here, it was easy to do. Moving on. All right, question 8. We have a histogram. Now I've put this data. Well, let's label the thing. So we're going to start with 17.5. Now it says it ends with 37.5, and we want 5 classes. Well, here's how we're going to find out what the class width is. I'm going to go 37.5 minus 17.5, and I'm going to divide that by 5. And I can see that's going to give me 20 over 5, or 4. So I'm actually going to add 4, 17.5 plus 4. That's going to get me to here. That's 21.5 plus 4. That's 25.5. Let's rewrite that. 25.5 plus 4. It's 29.5 plus 4. It's 33.5. And we're going to have to extend this. Put a 0 there. And then add 4. And that brings us to our 37.5. There we are. I'm going to take this data and I'm going to put it into a list. Lovely, we have a commercial. Damn it. All right. I'm just going to have to wait this commercial out. I was hoping to skip through it. Sorry about that. All right. Done and done. So we are here. And you can see. Oh, I decided not to put this into a list. That's right, after all that. All right, so let's see what we have here. Between 17.5 and 21.5. So let's highlight what we have. 17.5 and 20. So between 18 and 21. 18 and 21. I'm only seeing the 1. So let's draw that. You, of course, on your practice sets, you'll be able to drag and drop. We have to do ours manually here. Between 22 and 25. 22 and 25. Looks like we're, oops. Here, here. 22 and 25 here. And here. So I'm seeing 4. So again, you get to drag and drop yours. And between 26 and 29. 26 and 20. Yeah, 26 and 29. Let's see. 26 and 20 there. There we go. There. So it looks like 4. 30 and 33. 30 and 33. So I'm seeing here. No, that's too much. 30 to 33 is here. So I'm seeing 1, 2, 3, 4, 5 in this case. And between 33 and 37, it looks like we have 1, 2, 3 left. So we're up to 3. So just a quick recap. This is 1, this is 4, this is 4, this is 5, and this is 3. And here we are. Again, you can do yours much nicer than mine. Reyesberg Corporation is contemplating using a new glue in the construction of its laminated veneer lumber. Of importance to the company is the carrying load of the lumber. The company has tested 25 beams, including the new glue, recording for each beam the pressure in pounds per square foot at which the beam broke. The data collected are presented in the following histogram. So here we have our histogram with our percentages at the top, or our proportions at the top. And based on the histogram, find the proportion of carrying loads in the sample that are less than 880 pounds. Okay, so here is our cutoff right there. And we are looking for how much is that way. This answer is very simple. 0.16. That's it. That's the whole thing. All that 0.16. All right, here we have a dot plot. They call that the line plot in ALEKS for whatever reason. So over here, 6, 8, 4, 9, 4, 7, 4, 8. That's it. Yours will be even easier. You just click with the mouse or keypad or the mouse pad. All right, number 11. Each of 5 students reported the number of movies they saw in the past year. Here's what they reported. Find the mean. I'm going to do this the old-fashioned way. You could use one var stats if you wanted to. I'm going to do this one by hand just because it's important that we remember how to do this. 6 plus 14 plus 6 plus 13 plus 10. We're going to divide that by 5. So we have 6 plus 14 plus 6 plus 13 plus 10. And I'm going to divide that by 5. Divide by 5. And that gives me 9.8 movies. All right. The following list contains the number of hours that a sample of 9 middle school students spent watching television last week. So I'm going to reorder these in order. So 4, 6, 6. So next up is 11, 12, 13, 16, 19, 20, and I'm going to count these real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. And they said 9. And if you remember, the median is the middle number. So I'm going to go in from the outside by 1, and then in one more, and then in one more. Oops. This should be here. In one more, and then you can see we are converging here. So our median is definitely 12 hours. Now, if there was an even number of them, that would mean that we would have 2 numbers in the middle. We would have to take the mean. We'd have to add them up, divide by 2. But in this case, it was an odd number, so we actually had a middle number. All right. Number 13, we have the mode. I'm just looking at this, and I'm seeing a bunch of 16s. Let's see how many we have. 1, 2, 3, 4 16s. I'm seeing a bunch of 19s also. 1, 2, 3, 4 also. So we have 2 contenders so far. I'm also seeing a bunch of 20s. Remember, mode is the most frequency repeated number. Now, had one of these, they all have 4, so they're all the mode, but had one of them had 5, that would be the only mode. So the modes in this case is 16, 19, and 20. Those are our modes. All right. The following are distances in miles traveled to a workplace by 6 employees of a certain hospital. Find the standard deviation. I am going to use one var stats for this. Although we could do this by hand, but I'm not going to bother. You'll note that in list 1, I have the numbers here, the 22, the 16, 3, 45, and 28. So I'm going to run one var stats on list 1. So stat, calc, one var stats, and I'm going to run this on list 1. And I'm looking for SX. So my standard deviation is about, it says to run it off to 2 decimal places. So this is going to be 14.09 is my standard deviation. And this is going to be miles. All right, moving on. The heights of 8th graders are modeled using the normal distribution shown below. The mean of the distribution is 60.8. So I'm going to stop us right there and put that in. This is 60.8. And the standard deviation is 2.1. We have two blanks here. We have U and V, UV and W, I should say. We already have V. And we need to see how many standard deviations we're going at. Now, I'm going to add 2.1 to the 60.8. So 60.8 plus 2.1. And that's it. Now, notice that's a number between 62 and 64. 62.9. And again, I want to point out that this is a single standard deviation in that direction. So let's subtract from 60.8 minus 2.1. And again, on the first try, that gets us between 58 and 60. So this is, oops, this is 58.7. Now, I might need to add 2 standard deviations or even 3 standard deviations as we go out from there. But once again, this is only 1 standard deviation away. And 1 standard deviation away for us means that this covers 68% of the total school. If we went 2 standard deviations out, that would be the 95%. 3 standard deviations away would be 99.7%. We lucked out it was only 1, but on your practice test or even the real test, it could be 2 or even 3. You'll have to really notice, am I between the 62 and 64 when I go 1 or 2 or 3 standard deviations out. All right, this is called the empirical rule. All right, moving on. An amusement park conducted an internal audit of the wait times of its customers for the park's rides during a summer weekend. The audit found that the wait time for customers for the Shooting Star ride had a population mean of 21.7 minutes with a population standard deviation of 2.9 minutes. Now, those are populations. The park's head executive has doubts about the audit's finding concerning the Shooting Star ride. He hires an inspector to check these findings. On a summer weekend, the inspector takes a sample of 15 people, so now we're talking about a sample, at random, waiting in line for the Shooting Star. She records their wait times and finds that the sample mean is 20.3 minutes and sample standard deviation is 2.6 minutes. So what we're doing here is we're trying to match up the proper symbol. So a population mean is represented with the Greek letter mu. So that is the population mean. The sample mean is going to be X bar. The sample standard deviation is just S. The population standard deviation is that weird looking sigma there, that kind of circle with the hat. And of course, standard deviation squared is variance, so they could have asked us about the variance as well. All right, moving on. 17 of 21, Elm College and Mountain College are 2 local colleges. For each college, the distribution of ages of faculty members is clearly skewed. It's not symmetric. Yeah, the ages of faculty members at Elm College have a population mean of 55 years old and a standard deviation of 4.4. The ages of faculty members at Mount College have a population mean of 39 years and a standard deviation of 5.9 years. Dan is 50 years old and faculty at Elm College. Trey is 29 years old and a faculty member at Mountain College. So we're going to start out by finding the z-scores. Just a quick reminder, the formula for z is here. So let's take a look at, start with Dan. Dan is 50. The mean is 55. This is at Elm College. And standard deviation is 4.4. Let's see what we get. So I'm getting, it says round to 2 decimal places. So I'm getting about negative 1.14. And we'll take Trey. Trey is 29. minus, what's the mean at his college? 39 years old. And standard deviation is 5.9. Let's see what we get. 29 minus 39 divided by 5.9. So negative 1.69 is what I'm getting. Now, this is not going to give us very good information here. Oh, the part B. We'll do exactly that. Relative to his population, who is older faculty member? And again, this is a relative question. And in this case, the only answer that we can give is that it's unclear. They're both negative, so it really isn't clear who's relatively older. All right. 18 of 21. Here we go. After this year's census of its members, the local pilots association found that its members have a mean of 3,095 hours of flight experience with a standard deviation of 679 hours. Isabel is a member of this pilots association. The census shows that she has 4,210 hours of flight experience. Find the z-score of Isabel's flight experience relative to the experience hours. Okay, so Isabel, her z is going to be 4,210 minus the mean, which is the 3095. And that is going to be divided by the standard deviation, which is the 679. So let's see what we get. 4210 minus 3095 divided by the 679. And it says round to 2 decimal places, I believe. Yeah. So it looks like we're getting about 1.64 to me. Notice it's positive. So this means that Isabel's flight experience is 1.64, about 1.64 standard deviations above the mean flight experience of all its members of the pilots. All right. Next up. Now, again, this weird PDF version that I'm using here did not type out the last two, so I wrote those in before we started. So here we have test scores for 12 students in Mr. B's class. What percentage of these test scores are less than 88? So I put this into a calculator. And you can see the 82 and the 62 in my list 2. I'm actually going to sort list 2. I'm going to hit stat, sort A, meaning I want smallest on top and biggest on the bottom. I specifically want to sort list 2. And I'm going to actually list this out. So this is 62. Let's just wait, 62, 62, 67, 71, 75, 79, 82, 6, 7, 91, 93, and 95. Now I'm going to count these to make sure I have them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're good to go. And they want to know what percentage are less than 88. So let's find our cutoff. That looks like we are going to be right here. So how many are below 88? 1, 2, 3, 4, 5, 6, 7, 8, 9 of them are. So this means that we're going to have 9 out of the 12, which means we are at, that's going to be 9 divided by 12. So we are at 75%. Just to be clear, this is going to be times 100. This is 75%. This is what we call a percentile. We're given a specific location, and we want to know what percent is below that location. In this case, it's 75%. All right, two geometry classes with the same number of students took a final exam. And we have a box and whisker down below. So we have class A and class B, and let's jump to the actual questions. A score above 70 is considered passing. Which class had more passing scores? Well, that is definitely going to be class B. There's definitely a lot more information there. Let's highlight that. Class B, because if you look at where the 70 starts, most of the data on the class B is to the right of 70, whereas there's several data points that are well below the lowest data point on class B from class A. Which class had a higher median test score? The median is going to be defined for us right here. Here's the median, and here's the median. Which one is higher? That is definitely going to be sorry, one sec. I was wrong here. This is, they both have the same number. Because you can see 70 is here. So I did this cutoff weird from before. Here's the 70. So both of them have the same number. I apologize. All right. Which class had a, so the second one, which class had a higher median test score? That is definitely going to be class B. Again, here is our median test score, and this one's clearly above this one, meaning further to the right. Which class had test scores with a larger interquartile range? That's the big box. That is definitely going to be class A. It definitely has a bigger box. Meaning here, this is much larger than the smaller one. So this is class A. Which had the highest class score? That is going to be B, because this one goes further out than class A. Yeah. All right. And we are to our box and whisker plot. I put, so we have noontime temperatures in Fahrenheit of 22 world cities measured on the same day. I have put all of this data into my list 3. Another advertisement. Sorry about that. This is going to be a short one. All right. And you can see the 79, the 84, and so I'm in list 3. What I'm going to do first is I'm going to put this in, I'm going to list this in order, so I'm going to quit out of that. So I'm going to, in ascending order, that's list 3. Okay. So now what I'm going to do is I'm going to run one var stats, and that's going to give me my minimum, my first quartile, the median, third quartile, and the maximum. So stat, one var stats. And I need to change mine to list 3. Oops. List 3. And there are my data. So this is 35, 65, 73.5, 81, and 88. Now we are going to have to find the interquartile range and check for outliers. Now it doesn't say anything about outliers, but on the test you'll be expected to check for outliers. So I'm going to go down here. Next, I'll go here. IQR. Remember, is Q3 minus Q1. (81 minus 65). And my lower fence, remember, is Q1 minus 1.5 times the IQR. Is 65 minus 1.5 times 16. So this is 41. And down here, I'll do the lower or the upper fence is Q3 plus 1.5 times the IQR, which is 81 plus 1.5 times 16. $105. All right, so let's use this information. Actually, let's look at the list in order. That'll make it a lot easier. So here's our list. Do we have any data that is below 41? And the answer is yes, we do. In fact, we have 3 pieces of data that are below 41. This is no longer our minimum. The 35, the 36, and the 37 are outliers. So outliers. 35, 36, and 37. And our new minimum is now 48. Because that's the first one that's within our lower fence. Now let's go to the other end of that. Do we have any data points that are above 105? No, we don't. So we have the 3 outliers. And then we're going to have our, and to represent the outliers, you of course just have to use a dot. But at 35, we have an asterisk, 36 and 37. Those are all outliers. So this is 35, 36, and 37. And then our actual box and whisker plot is going to start at 48. So 48 is down here. Next up is 65. Then 73.5, so 73.5. And then 81. And then 88. So we have our box. Again, you'll be able to do this much better looking with the computer. There is our box and whisker plot, our modified box and whisker plot that includes outliers based on the interquartile range. Good luck on your test. I hope you ace it, and I hope this was helpful.